Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we speak with the Vice President of Engineering and New Product Development at Hoonigan, a leading automotive aftermarket products company. Our guest had an extensive career in automotive product development space, working with a wide range of products from accessories to complete specialty performance vehicles. He's a proud father of 3 adult boys, a pilot and off-road racer, and he spends his free time in Baja California with the Long Beach Racers team. Ted Moncure was born and raised in Long Beach, California, where he still lives today with his wife of 31 years. A graduate from California Polytechnic State University, Ted worked at Toyota for 22 years, including 10 years leading Toyota Racing Development's performance accessory team. After leaving Toyota in 2015, Ted joined Transamerican Auto Parts, where he spearheaded the engineering of trucks and off-road products under the 4-Wheel Parts brand. When 4-Wheel Parts was acquired by Hoonigan in 2021, Ted took the role of VP of Engineering, overseeing a wide range of products from wheels to suspension systems, accessories, and lighting. In our conversation, we discussed the intricacies of developing aftermarket suspension systems for trucks and SUVs. Ted shares his experience on the process of measuring vehicles, evaluating safety systems, and fine-tuning suspension to maintain stability and performance. We also discuss the challenges of staying compatible with vehicle software and how aftermarket changes can impact the vehicle performance. Ted emphasizes the importance of testing and validation in product development, the need for rapid development cycles, and the role of 3D printing in modern engineering. Ted's wealth of experience makes this a fascinating discussion for anyone interested in motorsports engineering. Let's get into it. Hey, Ted, welcome to the show.
Hey, thank you very much for having me.
Yeah, it's great to have you here. So I tell everybody to start these. I started Impulse 25 years ago. I worked for a company out of school for about 3 years, and they had all facets of product development under one roof. Kind of saw the writing on the wall that they weren't in it for the long haul, and I started Impulse, and we help companies design products. How did you get into product development?
So I started at Toyota right out of college, out of Cal Poly, in a rotational kind of engineering management training program. And I got to work in a bunch of different departments, which was cool. I worked in quality, I worked down at the port, I worked in lean manufacturing. And then I did a stint through the accessory development and vehicle conversions department, where we developed all the accessories, and we actually developed things like Celica convertibles. And I'm an automotive guy, have been my whole life. And so I just love the idea of making things. That's kind of what, when I went to college, I kind of wanted to build race cars. And then it ended up working for Toyota, and I race off-road and get to kind of get my itch scratched that way. But yeah, making cool stuff has been kind of the central focus of my career.
Very cool. So what are you doing? What's your current role, and what kind of products do you develop now?
So right now, I'm the VP of Engineering and Product Development for Hoonigan. Hoonigan is a automotive aftermarket company. Many people are familiar with Ken Block, who started Hoonigan as a media company, and then Ken sold the business to Wheel Pros, which was the biggest aftermarket wheel company in the United States. And then they rebranded the whole business, and they in turn purchased the 4-Wheel Parts brands, purchased Terraflex, ReadyLift, Logic, Morimoto lighting. So we've got this big giant collection of automotive aftermarket brands, and basically what I do is I lead engineering and new product development for that business.
Very cool. So tell us about the product that you want to talk about today and why you chose it.
Yeah, well, suspension has been kind of my specialty, because of my off-road racing background ever since college. And at Toyota, I was lucky enough to get to run the TRD group for 10 years. The last 10 years I was there, where we developed the Baja Series Tacoma and the Ultimate Edition FJ Cruiser and the TRD Pro line of vehicles. And so that's kind of my passion, right? And then when Toyota moved to Texas, I didn't want to go. And I wanted to stay in the truck and off-road space. So I went to 4-Wheel Parts and then led the engineering for all the suspension and accessories and drivetrain products that they developed. And then we got acquired by Wheel Pros, which became Hoonigan. So today we're going to just talk about suspension, truck and off-road suspension development, which is what consumes most of my time here at Hoonigan.
Very cool. I'm interested to hear more about it. So normally I would ask, tell us more about the product, but what are the features and the things in the product that we, just looking at it, we wouldn't realize or understand. So can you get into that with suspension?
Yeah, so suspension's a pretty wide-ranging business, right? On the low end of the market, you've got what we call level lifts, which are just spacers that basically set the vehicle ride height so you can put a bigger wheel and tire on it. Because most customers, when they go buy a truck or a Jeep, they want it to look cool. They want to put a bigger off-road tire on it, a cooler looking wheel. And to do that, you need a little bit more clearance. Also, the factory, when they set up the car, they set it up with the nose a little bit low, which there's a bunch of reasons for that, right? From aerodynamics, fuel economy, emissions, coast down testing, just load carrying capacity, etc. But that's not really what looks good, right? What looks good is to have the vehicle kind of sitting more level. So at the low end, we develop that kind of stuff, but we try to take a little more care than a lot of the cheap, companies that are out there in the aftermarket that are just, putting spacers in without really doing the engineering to understand the effect it has on the rest of the vehicle system. So you end up with, tie rod ends failing and CV joints failing and things like that because they overstress all those and ball joints and stuff. So they get a bad rep. And then, we move up from there to, people want to go bigger. You want to put a 35 or a 37-inch tire. So you go with a bigger lift. And now we're changing steering knuckles and, shocks and springs. And sometimes we're adding whole cross members to the vehicle frame to lift it up higher. And then there's the whole performance segment, which is where I'm, where I live, right? As an off-road racer and a guy who spends a lot of time camping and overlanding and playing around down in Baja pre-running, I don't really want it to be tall. I want to get the biggest tire on there that I can with the lowest lift height, but I want the suspension to work. I want to have a lot of articulation, wheel travel. I want to have dampers that are, controlling the vehicle properly so I can go fast. And so there's this kind of emerging premium space that started, I would say, probably early 2000s. We started building vehicles that had these kinds of suspension on them, on our personal vehicles, desert racers, building pre-runners. They've been building pre-runners for years, but it started to get mainstream, the whole performance shock and suspension side in that time. So for the last 20 years, you've seen that part of the market growing. So these big 6 and 8-inch lift kits are still cool for a lot of people in the country, especially people who go into the mud or people who just want to look cool. But really, where the market's going is in a performance suspension system that may add 2 inches in height to the front of the car just to level it out and give you the bump travel that you need to be able to go fast. But really high-end shock absorbers going beyond where the OEMs can go. And that's what we did with TRD Pro, right? That's what Ford did with Raptor. And now they have a whole range of Raptors. And so basically just, getting rid of, for years, trucks came with a 50 millimeter shock, a twin tube 50 millimeter shock that would just boil. So you could drive it down a fire road to your fishing hole, but you can't take it down into Baja. You can't take it on a trail and try to go fast. So, now everybody's running 2.5-inch bypass shocks, in some case 3-inch shocks with reservoirs and adjusters and, smart technology. So there's a ton that's gone on in that development space. And you see it in the UTV market, especially, right? Where they've got 20 inches of wheel travel and 25 inches, I think, on the new Pro R Razor. Just, it's the closest thing you can get to a trophy truck that you can buy out of a dealership. So then people want, the downside to a UTV is you can't really drive it down the freeway, right? You can drive it on local roads and whatnot, but you can't take it for a weekend and go down to Baja or go out into the desert overlanding with a rooftop tent and go camping and bring your friends and have an air-conditioned cabin and all that stuff. So being able to take your truck and then modify its suspension and wheel and tire package and be able to use it for those kind of things and still drive it to work on Monday, is a really good value proposition. So what we do with our TerraFlex brand is Jeep specific, hardcore, rock crawling and trail running. And then our Ready Lift brand is kind of more broad for everybody in the truck and SUV kind of off-road space.
Okay, it's very interesting. So I've got a ton of questions. So you sell a kit, right? They don't come. Somebody won't come in and just buy a shock. It's a kit for the entire suspension. Is that how it
Yeah,
would work?
that's our preference, is to sell a whole system. We do sell, both through our Falcon Shocks brand. We'll sell individual shocks. We also have Pro Comp shocks, and we sell a lot of shocks. But that's typically what happens is people buy a suspension system, and then they will upgrade their shocks within
Okay.
that system. So, but the way we prefer to do it is just to buy our whole system, because it's all engineered to work together. It's got appropriate clearances, and we've done the validation to make sure that the vehicle is still compliant with all the safety requirements, like FMVSS 126 for vehicle stability control. That your radar cruise control system still works. Whereas if you piece something together yourself, or you go with a company that doesn't have the sophistication to do that work, you're really kind of a guinea pig. You're going to get what you get, and hopefully it'll be okay.
Interesting. So these kits that you design and sell and all that, is the car, it is still drivable on the road then?
Absolutely. Yeah, I mean, we do have certain uh, Terraflex has a couple of hardcore coilover conversion long arm suspension kits for guys that just want to tow their rig to the trail. But
Okay.
but for the most part, everything we sell is FMVSS 126 compliant, and it is intended for on-road use, on and off-road use.
Sure. Interesting. So, we've developed literally thousands of products with companies, and every one of those development journeys is a little bit different. Walk us through, like, what's the development like for one of these suspension systems?
Yeah, so it varies a little bit by the type of system, whether it's a level lift, or, we have a thing called an SST kit, which is like a 3-inch kit, and then you go up to like a 6-inch kit. But generally, the process is the same. The first thing we do is we get our hands on a development vehicle. We get our hands on all the relevant data that we can. So some of the OEMs provide CAD data of their vehicles through SEMA, and you'll have nominal CAD data, and some of them don't. Like Toyota famously does not share information with the aftermarket. So you've got to reverse engineer it. So we'll start by measuring our development vehicle to get an idea what the nominal vehicle condition is, what its ride height is. We have an evaluation process where we'll go and evaluate all the vehicle safety systems, like vehicle stability control, radar cruise control, parking sensors, all those things, backup camera vision, with an unmodified vehicle, right? And then we'll do an alignment sweep, and we'll really understand where this vehicle is with relationship to all the things that we're going to need to know about it later on. And then we go and we kind of create, what are our requirements for this kit? Is it based on a tire size? Sometimes our brand manager will just say, hey, do what it takes to fit a 35-inch tire. And so if that's the case, then you really start with, okay, what's the wheel well condition look like? Where's the bump stop need to be? What's your stroke look like in your suspension? Because we want to maximize our stroke. Like I said, a lot of the aftermarket will just stick a big giant bump stop spacer on there, and not really take into account that now you've gotten rid of all the jounce travel, and you're limited with the amount of rebound travel you have, because you're lifting it up already. So the things ride like hell, and lift kits and suspension systems in general get a bad name because of those poorly engineered systems that are out there. So our goal is, if we're going to limit bump travel, then we want to add some rebound travel. And we've got engineering standards around, sorry about that. We've got engineering standards around how much rebound travel you've got to maintain on a system in order for it to ride and perform well. Because one of the things when you start to do stability control type testing and things like that, is you want to minimize, one of the requirements is you can't have two-wheel vehicle lift. So when you get out there and you've got a steering robot on the car and it's turning at 360 degrees per second, you've got to make sure the tires stay in contact with the ground. And so if you limit your droop travel, it's a very easy way to fail the test and get two tires to come off the ground. And the reason we're doing it is to maintain our safety for the customer, right? We want to pass the regulatory compliance checks, just to do our due diligence as a professional company. But the point of those are to maintain the safety and stability for for the customer. And there's a lot of customers who have bad instincts when things start to go wrong and a vehicle starts to slide whether you're in ice and snow, whether you're on the freeway and you have an emergency maneuver. So making the vehicle kind of confident and natural feeling, making it able to, have stability and recover is really important. And so we spend a lot of time working on making sure that, things like spring rates are right. And that, like I said, your wheel travel is set up properly so that you've got the greatest capability in terms of we're trying to maintain or improve on the OE vehicle's capability.
Interesting. So, like stability control and cruise control and things like that, a lot of that's computer assisted, right? So,
Yep.
is there a balance between like you guys are engineering some of that in, and then is there also like, are you editing software or firmware?
Unfortunately, we can't edit the software because it's all proprietary. This is one of the areas where there are a few federal motor vehicle safety standards like 126, and there's a new one coming in 5 years for pedestrian automatic emergency braking. So there will be some requirements that the vehicle has to hit where there's an objective test that we can do to confirm the vehicle's still compliant. But all the OEMs have a different way of complying with these, and there's no requirement that they have to open up their code to us. So, so it's all locked down and proprietary, and so we can't get in there and reflash the vehicle stability control programming. So our whole thing is to understand where the limits are on the base vehicle, and that's why your original evaluation is so important, because we're trying to determine functional equivalence. And so then we can tune our suspension system to try to minimize, if the vehicle is really roll sensitive, then, we can stiffen up the spring rate or, change sway bar or something like that to basically allow it to be taller and still have similar roll characteristics.
Interesting. So it's 100% engineered then. It's not, you just said you can't change the code. So interesting.
Yeah, sadly. I mean, we play with sensors a little bit where we can, but it's all mechanical. We're not EEs. We've looked into some CAN bus work. That's another story though, but we haven't been able to do it in a way that we would feel confident releasing it into the market. And the OEMs, they own their software, so they are very protective of it. And you can see it in the vehicle tuning market, where they're doing everything they can to stop people from tuning their engines. And then, so basically, the folks that are tuning engines are having to constantly respond. They're in a battle with the OEMs. And the OEMs are changing their algorithms every year and mid-year when they can, and then the tuners have to go and find a way around it. So it's a whole different business model than what we're doing.
Yeah, that's interesting. Does tire diameter affect cruise control? Because I know back in the day, if you put a different tire on, it changed the speedometer.
It does. Most cars are still using a wheel speed based system, and so there are calibrators available that many of our stores will install to keep speedometer calibration within 3%. We also have specialized in doing calibration of like your safety cameras. So, we spent a lot of time. In fact, 2016 or 17, Toyota had this Toyota Safety Sense system that came out, and they put out a letter saying you can't modify your vehicle because it will no longer comply with the Toyota Safety Sense. And so that put a real damper on our business with all the dealers. One of our businesses sells and upfits vehicles for dealers. And so They all of a sudden, the Toyota dealers stopped buying from us and everybody else. So we had to do some research. And luckily, I had an engineer on my staff who used to work with me at TRD, and he knew the calibration protocols. And so we went and worked with a local dealer to modify the vehicle in multiple steps from level lift all the way up to a 6-inch kit, and then evaluate the safety systems, just like we did when we did all this at TRD, and then calibrate the systems. We did uncalibrated, we did it calibrated using the Toyota spec, the calibration spec, and the Toyota tools. And then we even got a Toyota field technical specialist and a Toyota master tech to come and ride along as we did this evaluation to gain consensus that, these vehicles, these systems work. Your blind spot monitor still works, your radar cruise works, your emergency braking works, your ABS and vehicle stability control still work. And then I put out a letter saying that, hey, this is what we did to validate these systems. And we found that if you buy our systems and you install them properly and calibrate them properly as instructed, the systems all still work. And so that allowed us to get back in this business, but it also motivated Toyota to come up with their own lift kit. So now Toyota's got their own. My old group, the TRD group, has their own lift kit for certain vehicles, and you can see the differences in the aftermarket and the OEM. Like their kit costs triple what our kit costs and has a lot more components. Because Toyota's famously conservative in their engineering standards, and so doing it the Toyota way, this is what it takes to get it approved by Japan. So anyway, it was a very interesting kind of dynamic.
Yeah. So other than Toyota having their own lift kit, do you guys kind of have a corner in that market now?
Well, everybody else has just kind of come on in behind us and copied my letter. They haven't done the work, right? But they've just copied my letter and said, "Oh, it all works," And basically, that's what has happened with FMVSS 126 testing as well. We still do real FMVSS 126 testing using a vendor and using an OEM proving ground, and we use engineering judgment to decide which vehicles need to be tested to confirm that it's going to work on a range of applications, just like we did at Toyota, right? We did the shortest and tallest vehicle that was available in the spec, and we used engineering judgment to say if this vehicle passes, then lower and longer vehicles are going to pass, for instance. But what a lot of our competitors do is they started hiring simulator companies to basically just do a computer simulation and then make a judgment based on computer simulation that it is acceptable. But we learn a lot through real testing. So it's an expense that we have in our budget that we invest in, but it makes me feel like I know a little bit more than our competitors do about what actually happens at the limits. And we found some things, which our competitors haven't found, right? So I feel like our products are the safest ones out there.
Sure. It sounds like they are. How often do you develop a new kit? I mean, I know like a lot of these vehicles are platforms, so they don't change a whole lot year to year. How often do you develop a new system?
Yeah, so we basically try to look out 3 to 4 years at all the platforms we support and find out when the new vehicles are coming, and we bake that into our annual plan. So typically in a given year, there's 1 to 2 new vehicle platforms. Like in the last 12 months, we had the Super Duty. Ford Super Duty had a significant change in 23, and then the 24 Toyota Tacoma came out that was all new. It was on the TGNA, I think they call the platform. So it's kind of like the Tundra, but it's different. So what we do is speed to market is really important to us because of the fact that we're selling to dealers. They want these products as soon as the new car hits the lot because that's the most profitable time for them to sell the product, right, in the new product life cycle. And most of our competitors don't invest the resources we do to get to market first. A couple of them famously do, because you get this little blip in sales, and then it kind of stretches out. And then 3, 4, 5 years after the car launches, when it starts going to the second owner, they start to really accessorize the vehicles. So that's when you have a lot of units in operation. That's when it gets really lucrative. But our feeling is, if we jump on it first, number one, we learn everything there is to know about the new safety systems, the new way things work, and that helps us. It gives us a little advantage because part of it is new product development and part of it is maintenance. And so Toyota may launch a new platform this year, but then they may, on another vehicle say, well, we're going to update this other system to the same new system that just came out on the new Tacoma. So when we learn about it on the new Tacoma and then it hits as a mid-year refresh on a 3-year-old Sequoia or something, we already know how it works, and it gives us an advantage. As well as, like I said, getting to market first allows our dealers to be able to offer the product, because when customers buy, even if you're buying this car secondhand, when the new vehicle came out, you were looking at what everybody was doing. You're going to the SEMA show, you're like, wow, that thing looks badass, right? So then in your brain, you're like, I like those wheels. I like that lift kit. I like that rooftop tent. I like that bumper. So then 5 years from now, when you actually get to buy a used vehicle, in your brain is still what you thought was cool. And of course, during that time, somebody might have come out with something cooler, and you might change it. But by and large, the pioneers have a first mover advantage.
Yeah, interesting. Um, is it always like, are you able to, when there's a refresh or a new platform that comes out, are you able to just kind of adapt your existing kit, or is it pretty much ground up, you're starting over?
It all depends. That's one of the big purposes of the original scanning, 3D scanning, and vehicle measurement that we do. So, for instance, on the Super Duty, they had made one big change to the radius arm mounts on the frame. Pretty much the whole rest of the kit carried over. So that was really fast for us to be able to take parts off the shelf and get first to market. The Tacoma was a clean sheet. It had a couple of things, like I think the control arm spacing, and maybe the ball joint carries over from the new 22 Tundra. So the work we did to be first to market on that paid off, but everything else was different. It's a different car, different spring rates, different frame width. So we ended up basically developing all new products for that. But now the Land Cruiser just hit, and probably 80% of the parts in our Tacoma kit are going to work on the Land Cruiser. So that's going to give us another advantage. And then 4Runner's coming out in the fall, and I have it in good authority that that's going to be very similar to the Land Cruiser. So we try wherever we can to use parts bin engineering and carry something over to a new platform. And then, it just kind of depends on the OEMs and how significant the changes are. And some of them, like Toyota, will do a whole new platform. Ford will just keep modifying their existing platform every year. And so they'll have 9 engineering changes lined up for the next 4 years. And they don't necessarily wait for a model year to introduce them. GM famously did this with knuckles. They switched from steel to aluminum knuckles, but they built both vehicles side by side, and they had 2 different ball joint tapers. So there was no rhyme or reason to it that we could determine. So it was very difficult. We had to offer 2 kits, and we had to tell the customer, hey, you need to determine if you have steel or aluminum knuckles before you order our kit. So luckily, most of these bigger kits that use new knuckles are installed by a shop who can stock both kits on the shelf.
Okay.
But do-it-yourselfers, that could really hurt,
Yeah, that's interesting. When you go to measure the car and scan the cars or the trucks, do you work with a dealer, or do you have to buy one, or how does that work?
It all depends. So we set our capital expenditure budget up for the year with all the vehicles we plan to buy, which are the ones I use. The Automotive News Future Product Pipeline. It kind of gives you an idea of when all the manufacturers' new vehicles are coming out. And so we look at all our heavy hitters and we say, all right, we're going to buy those vehicles, and then I'm going to sell vehicles from my development fleet to fund it, right, or to fund most of it. And we do our capital expenditure plan. Then when we get vehicles that, like Land Cruiser, is not on our plan to buy one. It's an expensive vehicle. It's only 35,000 units a year, so it's not going to be a huge business for us. So we borrowed one from a local dealer, and we have relationships with a lot of these dealers where we can borrow a car, use it for a couple of weeks, give it back to them with a level lift and wheels and tires on it, and they're happy and we're happy. So we're not as fast though. So my goal, I will fly someone anywhere in the country. If it's a number one priority vehicle platform, I want to buy the first one that I can get my hands on, and I'll fly someone anywhere they need to buy it and drive it across country over the weekend, and we'll have people waiting to scan it as soon as it pulls in. We've even borrowed cars. Like one time, a friend of mine who's a kind of a famous journalist and podcaster got a hold of a new vehicle that we couldn't get a hold of, and so I took him to dinner. And I have a little race shop. Our Long Beach Racers team has a little race shop in Long Beach. So we basically left the vehicle at my shop. I took him over to dinner and have a few drinks. And my engineers came in, put the thing on the lift, took it all apart, scanned it, and thrashed, for like 4 hours and put it all back together. And then, he took off and went back and handed it back to the OEM, and they never knew that we had the vehicle, but it gave us a leg up. So there's a lot of that going on where everybody's competing for this info. And one of the cool things that Ford did on the Bronco was they actually selected our company along with 2 or 3 others to give OEM CAD data to in advance of them releasing it to SEMA. So we actually got prototype CAD data, a year before the vehicle launched. And that allowed us to have a full line of suspension, bumpers, everything developed, for that vehicle when it came out. The downside to that, and we got to go to their manufacturing plant and fit parts up, but we didn't get to do a lot of drive evaluation. And so the downside to that was, like on our bumpers, we didn't get our parking sensors oriented properly. And so they picked up the corner of driveways. So our first customers who bought those, we ended up having to 3D print some parking sensor bezels to reorient the corner parking sensors. So that's a case where trying to do simultaneous engineering in the aftermarket and OEMs without having everything that the OEMs have who do simultaneous engineering, that can always take some risk.
Sure. Very interesting. So I was going to ask if you got data beforehand, and you just kind of explained that. So in the case where, like a Toyota, you have to wait for a car to come out, let's say you get one day one, what's the timeline look like to develop a kit?
So we try to scan and measure the car in 2 days.
Okay.
That's our goal. We've got a pretty extensive checklist, right? And so we try to first do our measurements, alignment sweeps, ride height, rate the springs, do the baseline drive eval, then take it apart, scan parts, and then get started on developing the products. And we'll have the products staged. Like, we're going to do a level lift first because it's the easiest thing to do, and we want to get it to market quickly. And then we're going to do like a 3-inch SST kit, and then we're going to do our 6-inch knuckle kit. And so we can get a level lift on, we can build 100 of them in R&D and get them on the shelf within 2 weeks of us getting a new car, including measuring, driving, evaluating, and we'll actually build them right there with our engineers and fabricators. An SST kit is going to take 3 to 6 months, depending on if we have to develop a new ball joint or something like that. If we can use a ball joint for another application and the taper, the length and travel are correct, we can make an upper control arm. Springs take a long time, but generally 3 to 6 months we'll get to market with that product. And then a full 6-inch lift kit that has new cross members and new cast knuckles. That steering knuckle takes a lot of engineering, a lot of surfacing. We want to build prototypes and do all of our drive evaluation before we invest in the tooling that it takes for a big casting like that. And so that's going to take 9 to 12 months to get to market.
Wow. That's amazing that you're, I mean, in 2 weeks you can do a lift kit, and that's pretty fast.
And then, well, the big thing that we have been trying to solve since Hoonigan bought us, back in the 4-wheel parts days with ProComp, we would get first to market. We'd build 100 kits out of engineering, but then our manufacturing team wasn't fast enough to get production quantities. So we would launch, beat all of our competitors, get a huge sales spike, sell out within days, like 2 days, if you only have 100 kits on the shelf. And then we'd be out of stock for 90 to 120 days while manufacturing got spooled up. So one of the things we've been trying to work with now in the Wheel Pros Hoonigan world is working with our supply chain and our manufacturing teams, so that while we're doing this development, as soon as we have the bill of materials hammered out, the supply chain team is starting to procure the material that we need, and then our manufacturing team's ready for the handoff. And so we've really gotten better at that. So what's powering our success this year on Super Duty and Tacoma is that not only were we able to get to market quick, but we had the volume required to capitalize on the spike in sales that we got at the beginning. And so that's really helped us it's really helped our year.
Very cool. Do you guys do all that manufacturing in-house, or do you contract that to vendors?
We do both. Generally, we've got a 120,000 square foot, I think, manufacturing center in Ogden, Utah for ReadyLift and Zebros, which is our UTV brand. And then we've got Terraflex in West Jordan, Utah, has a pretty big manufacturing facility as well. And then Logic, our air suspension company out in San Luis Obispo, has a somewhat smaller manufacturing center, all co-located with our R&D centers. So those products are manufactured locally. Eventually, we'll still source the products, or at least components, overseas to bring the price down. But we want to get to market quickly. So we'll take a gross profit compression to get to market quickly, and then we'll work with supply chain to try to improve the GP going forward. things like wheels, we have a facility in North Carolina that does really high-end machined billet and multi-piece wheels. But for
Mhm.
your typical cast wheel, those are coming from overseas. So we're not as quick to market with a wheel. But wheels are generally very standardized, and so we have something in our system that has the right PCD, the right center bore, the right width and offset, so we can get to market relatively quickly until GM comes up with a bigger brake caliper or Toyota comes up with a 60 millimeter offset or something that's non-standard. Then we'll have to work with our vendors to get those made quickly. We'll design it, they'll manufacture it, but the rest of our businesses, and then lighting is kind of the same way. We design all the lighting here in the United States, but it's all manufactured by vendors overseas. And
Okay.
then we basically just have to work with them to get it made as quickly as we can.
Yeah. Very interesting. A minute ago, you mentioned having to 3D print I think it was a parking sensor for the bumper.
The
Um,
bezels, yeah.
yeah. What does prototyping look like? I assume you're not 3D printing a lot of this stuff to evaluate it. I assume you're
Yeah, a lot of the
machining.
metal, a lot of suspension wise, we'll 3D print little parts, just for test fit. But generally speaking, we're making things out of metal. So we've got a laser. Our R&D facility has a laser, a press brake, a CNC center, everything you need to make prototype parts really quickly. And then we make our own tooling and fixtures as well. We've got manufacturing engineers who will design those as soon as we finish prototyping the part. So it's a lot of tube bending, sheet metal bending, laser welding, and even when we make a knuckle, we'll usually make a fixture, take the existing steering knuckle and cut it, and then extend it. Put the ball joint where it needs to be, put the tie rod in where it needs to be, because tie rod placement's really critical to all your steering ratios and how the vehicle. Most cars have steering angle sensors. Some of them even have steering rate sensors. So you've got to keep the ratio between how fast you turn the steering wheel and how fast the wheels turn proportional. So it takes a lot of engineering as you're starting to move your lower control arm down, but leaving your steering rack where it is, considering bump steer and everything else to make sure that you have that system work right and you don't get a whole bunch of toe change or bump steer or other bad things that can happen if you're not
Yeah,
careful.
that's interesting.
But yeah,
So,
we'll actually cut it up and then extend it with sheet metal,
mhm.
or chunks of steel, depending on how the knuckle works, or aluminum for an aluminum knuckle. And then we'll get it to the point where you can drive on it. And they give me crap sometimes because I bend and break things because I kind of am hard on everything on purpose to try to make sure it's strong enough. But
Sure.
the knuckles, yeah, they're a little bit fragile when you chop them all up, and they're critical because they're holding the wheel on the car. So anyway, that's kind of an art. We've got a couple of guys that are good at it, that have done it for quite a while. So the engineers figure out where it all needs to go, and then we've got some really good fabricators that can take a drawing, right, and turn it into a part that actually has the right tolerance.
Sure. Sure. With all the products Impulses help design, there's always some kind of challenge that comes up. And I know we're not talking specific product here, but what's the biggest challenge you have in developing these kits?
Um, I think compatibility with the vehicle safety systems is probably the biggest one. I mean, you're always looking. One of the first things I did when I came here was put in a clearance standard because the aftermarket has wildly varying uh, outcomes in terms of quality. So
Mhm.
I wanted every engineer, every fabricator to know what's acceptable and what's not acceptable from the point of view of clearance, corrosion, things of that nature. So we've largely solved those problems. Most of our competitors, or many of our competitors, still have issues, and you can see it, witness marks where things are crashing against each other, steering binds up, whatever. But we don't have those problems anymore, right? So in terms of time, long lead components like a ball joint or a spring, where we have to create one from scratch and then get a vendor to make it for us, that takes time. But prototyping a whole system and getting out there and finding out that something's wrong with it, and you're engaging, all of a sudden when you make a right turn at 35 miles an hour, the vehicle's trying to grab inside brake and rotate the car because it's activating the vehicle stability sensor.
Mhm.
Like the yaw sensor isn't happy. Going back, having only mechanical things to solve it with, is a pretty big challenge. So that's why we spend so much time on it. And because sometimes if you don't do a good job baselining the car, these systems, because there are no federal safety standards around most of these systems, and each manufacturer is doing it their own way with their own vendors, there's a lot of areas where they don't work that well. The Wall Street Journal recently put out an article once NHTSA, the National Highway Traffic Safety Administration, mandated that within 5 years, vehicles are all going to need to have pedestrian automatic emergency braking. Wall Street Journal, just on the base vehicles, put out an article that said, you know what, these systems don't work very well, especially at night. So the state of the technology isn't as robust as what you expect from your ABS brake system, for instance. And so then we'll find these little corners where it just doesn't work or it freaks out. And if you don't find those in your baseline development, and then you encounter them, in your vehicle development, now you spend time chasing a problem that's a base vehicle problem that you can't fix. And that's the other. Driveline vibration is another one of those. You're changing all the angles in the driveline, and it's very difficult to solve those problems. So you've really got to understand them at the beginning.
Yeah, that's really interesting stuff. Switching gears just a little bit as we start to wrap up. This is probably my favorite question that I ask, just because everybody comes at it from a little bit different perspective. But what are some of the trends that you see emerging in product development?
Well, definitely speed. Speed being a virtue, it has always been important, but I think people are starting to see that the quicker you can develop a new capability, that's a capability by itself, right? And I would say iterative product development. Not very often do you get to do a new F-35 Raptor or something where you're trying to break the boundaries of every discipline all at the same time. Really, what I think you're seeing more and more of is do it the way we've always done it, change one thing. Dan Ward in his book Fire talks about one miracle per project, and that's how they developed a whole fleet of drones faster than they could develop a fighter jet. And each one of those drones, none of them can do everything the fighter jet can do, but everything the fighter jet can do can be done by a drone, by an individual drone at a much lower cost, and you can turn it around much quicker. So that idea, a disciplined product development process that doesn't get bogged down and that is very clear on what we need to develop and what we're going to do that's new that we've never done before, so that you can invest all your mental resources in, I want to learn how to work with aluminum. So this product's going to be the same as the steel product we did, but it's going to be lighter. And so we're going to learn everything that we need to know about how to design and manufacture and weld aluminum. And then we can use that capability on the next project that we do. And it's not a miracle anymore. It's just, part of our normal process. So adaptive learning for your team.
Yeah, very interesting. You've got a ton of experience. So reflecting on all the challenges you've had and the successes in developing products, what words of wisdom would you share with somebody looking to make a significant impact in the product development world?
The thing that took me the longest to learn is real innovation are things that customers are willing to pay for. So as an engineer, I always want to build a better mousetrap. I always want to make something cooler, faster, perform better, sometimes less expensive. Those are all the things we try to do as engineers. We optimize things. But if the customer's not willing to pay more for this version of the product than they were for the old version, then you've just put a whole bunch of cost and effort into it, and you haven't gotten anything out of it. So Scott Wine, for a while, Polaris owned 4-wheel parts for 5 years. And I served on the Polaris Technology Committee. And that's one of the things Scott Wine drilled into all of our engineers' heads was it's not real innovation unless the customer is willing to pay for it. So it changes how you think about, okay, if I develop this product, how much do I think it will sell for and what will it cost? And then it changes how you come to market, right? And it helps focus your team. So everybody has great ideas, and I love to have a bunch of little skunk works things that maybe aren't on the product plan in the works, because it keeps your engineers excited and stimulated, and they get to solve problems on the side. But I try to drive them towards thinking about, well, is the customer going to be willing to pay for this, or is it just a cool thing that I would like to have?
Mm-hmm. Yeah, that's really interesting. Yeah, that's good words. This has been awesome. Is there anything else you want to mention in regards to what we've been talking about or product development in general?
I don't think so. I mean, I'm excited to be here. I love developing new products, and I love, you know, I think the one thing is I love understanding how the customer is going to use the product. So early in my career, because I'm an enthusiast, I gravitated toward making things I want. And then somebody told me one time, Tom Morris, who's kind of a mentor of mine who used to run the Toyota Trophy Truck team, he said, "You're the 1%. Okay. Most customers aren't using things the way you are. You're beating the hell out of them. You got to think about the customer and you got to design for the 99%." So I do believe in that, but I believe designing products that'll work for the 1%, as long as you can do it and you're not adding a whole bunch of cost or complexity, make them cool. And people will pay more for things that are cool and that are durable. So I try to build that in without totally geeking out and turning into, getting into areas of the market where the customer just doesn't want to go. Like my personal truck has a long travel kit, has, bypass shocks and air bumps, but I've had to do a lot of cutting on the frame and welding and adding other things. And most customers don't want to go there. So as cool as it is, no one's going to get it. But the things I learned from that allow me to go, all right, let's go down one level to a bolt-on product the customer wants and put as much capability from what I have in my truck into this so that they can just bolt it on and they can go, and go down to Baja and play around and chase a race or whatever and feel safe and feel like, man, this thing's amazing. That's
Yeah.
the sweet spot. That's where you want to be as a product developer.
Awesome. This has been great. Before we finish, for somebody that wants to find out more, where can they find out more about the stuff you guys are
about our products? Yeah, you can go to Hoonigan.com or go to any of our individual brands. So Terraflex for Jeep suspension, ReadyLift for truck suspension, Logic with a Q for air systems, all the Wheel Pros brands for wheels, Morimoto lighting, and Zebros for UTV products.
Appreciate it, Ted. I appreciate you doing this.
Hey, thanks, Troy. Good talking to you.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.